Okay, our Unit 9 test is on circles coming up. So we have just 3 topics on this test. The first one is circumference and area. And then also those are related to arc length and sector area. So four vocab words that are going to be essential for this section to be able to do well. Let me autofocus this. Okay, the first one is a circle, which is the set of points that are equidistant, so the same distance from the center point, which is the center, from a given point, which is the center. So P is a point just anywhere in a plane, and then every point that's equidistant to that, so the same distance away, so this point is the same distance away from P as this point is from P, as this point is from P, so all of these points are equidistant from P. If you were to connect all the points that are the same distance from P, it would create a circle, and we call the circle circle P because that's the circle's center. A radius of the circle is a segment with its endpoints at the circle's center, so P, and then on the circle. So it can be any segment whose endpoints are at the circle center and then on the circle. So PB would also be a radius. A chord is a segment with endpoints on the circle. So both of the endpoints for the chord land on the circle. So it may go through the circles here, or maybe going through the circle through the middle, in which case it would be a diameter. So a diameter is a type of chord that passes through the center of the circle. So it still has its endpoints on the circle, it just passes through. So that the diameter is equal to 2 times whatever the radius is. So the radius again was from the center to a point on the circle. The diameter is from 2 points on the circle that passes, a chord that passes through the center of the circle. So anytime you're looking for the diameter, it's equal to 2 times the radius. Or if you're looking for the radius, you need to cut the diameter in half. Okay, and then we get into some formulas that are going to be time essential in order to be able to solve a lot of the problems dealing with these. So first of all, talking about what pi is. Pi is really it's a scale factor. Every circle is similar, and the scale factor for the radius to the circumference, it's 3.14 times bigger. So the 3.14 number most people know for pi, it really is telling us that every circle's circumference over its diameter has the same ratio pi, which is about 3.14. So every circle, doesn't matter what size the circle is, if you look at the length all the way around the circle, which is the circumference, divide that by the length across the circle center, then it's 3.14 times bigger, so a little over 3 times bigger the circumference is than the diameter. So the circles that are going to be important for us to know is that, first of all, circumference, what it is the length around the circle. And it really goes with perimeter. So perimeter would be like the length around a polygon, so maybe a 4-sided figure like the box that this is enclosed in. We could find the perimeter of that. Circumference is really just used for circles, so it's the perimeter of circles. And again, we said it's the circumference is equal to the 3.14 times the circle's diameter for any circle. So it's always 3.14 times bigger than its length across, is how long it is around. Another way to write that is that it equals 2 times the radius times pi. Okay, so because the diameter equals 2 times the radius, so d equals 2r, we can replace the d in the formula with 2r, and then it's the same. Okay, and again, diameter is the length all the way across the circle, and then the radius r is the length from the center of the circle to the circle itself. Okay, so if you're trying to find how long it is around it, we know the degrees around it is 360 for any circle, but the length, it could be in feet, it could be in inches, it could be in centimeters, is how long, if you were to start at one point and walk all the way around, how long you would walk. And that's the length of the diameter times 3 and some change. Okay, the area of the circle is how much is covered, how much space is covered. So area, we think of like this shaded piece, so like a plot of grass maybe, or pizza or something that is taking up a certain amount of flat space. And that's calculated by pi, so it's always 3.14 times bigger than the radius times itself, so 2 times the radius times itself, radius squared. Okay, and then arc length is a part of this. So arc length is the length of an arc. So it is the length of part of the circle. Okay, so let's say the circle's length from this point all the way around is, I don't know, 100 feet. Arc length is saying, okay, well, what about from here going around to maybe this spot? How far is that? So what is the length of just the arc? So the full enclosed figure would be a circle, and arc is just a part of that enclosed circle. And then that is always, it's going to be a percentage of the total. So just like your grade, if you were trying to calculate something that you had like 30 out of 68 points on a test, and you wanted to figure out your grade, you would do 30 divided by 68. So you're figuring out what percentage of the full 68 points you got. So percentage of the circle that we're working with times the full length of the circle would tell us the length of that particular arc. And the percentage is calculated by the degree that this arc is. Okay, so this is in terms of degree over 360, because that's the total degrees for a circle. So basically we're figuring out, okay, if we had a 90-degree angle, we'd have 90 over 360, so a fourth of the circumference. And again, we can use 2 pi r or pi times diameter for that. Sector area is a slice of the area, slice or part of the area. So instead of having the whole piece of a pie, maybe you have to share it. Okay, so we want to figure out what the slice would be, and it's going to be a percentage of the area, because it's not the full area. So you're taking a degree. This degree tells us about how much out of the total 360, because that's how much the circle would be, that we're dealing with. So what percentage of the area are we using? Only r gets squared, not the whole thing. So just the radius gets squared, but you don't square pi. Okay, so those are our formulas that are going to be pretty essential for us to understand in this unit. Okay, looking at the next page, the back of this page, we are given the directions to find the area of the sector and round it to the nearest hundredth. So we know the full area would be, if we did pi times the radius squared, we only want a percentage of that. We only want 35 out of 360 of that area, which is pi r squared. Okay. So the area of the sector, again, is the percentage of the full area. Just like if you got a 30 out of 68 on an assignment, you do 30 divided by 60 times 100, which would be the full grade that you could get for the assignment. If it's a 100-point assignment, you would do your percentage divided times the 100. We're figuring out 35 degrees out of a total of 360 is what percentage of the full circle's area that we want. And then we just type that in to the calculator. That one doesn't work. So 35 divided by 360. So it's really close to 10% of the circle's area is how much we want. And then we're going to times it by pi, times it by 7.5, and square that. So this is just telling us the 7.5 squared until we hit the equals button. So 17.18 to the nearest hundredth. And area is inches squared. because we did 7.5 is in inches and we times it by another inches, so we have inches squared. So all this gets typed in together. Everything on the numerator is multiplied, and then this 360 is divided. So you go ahead and try these next couple, see if you can get it. I'm going to do the next one just a second. Allergies are kicking in. Okay, so sorry for the long break, but this is the next one. It gives us 118 is this angle, which is this arc as well, but it's not the one that's shaded. We want the area of the sector that's shaded, so we would do 360 is the total degrees around the full circle, so here to here would be 360 degrees. We want to subtract out 118 because we don't need this degree, we want the shaded part because that's we're finding the area of the shaded sector. Okay, so we do that. It's 242 for this degree, which is this angle. All right, so then we're trying to still figure out 242 is what percentage of 360, and then we're going to be timesing that by the area. So 242 divided by 360 times pi times 4 squared equals. Okay, so that's all the work that you would need to show. We're saying 242 out of 360 is about 67% of the circle's area is how much the shaded part is. Okay, number 3 is a little bit different because they give you the diameter here. And in the formula you need radius. So remember, if we cut the diameter in half, that gives us the radius. So the radius for this problem would be 13. And again, they give us the non-shaded arc. We want the shaded arc. So we would do 360 minus 57 to get the non-shaded arc. So this arc is 303 degrees. So again, 360 minus 57 gets us this part that's shaded. Okay, so we want to figure out how much 303 is out of the full circle. What percentage of the circle are we working with? It is 84% of the circle, so that's what that means, 84% of the circle. Timesing it by the area of the circle, which is pi r squared. That formula is on the front. So timesing it by the area is about 446.87 meters squared. Okay, so these are all pretty much the same process after that. You're having to figure out what the degree of the arc of the shaded portion is, and then that over 360 times the area of the circle. In this case, if you have a part of the circle, let's say shaded, that's not, you don't know a bunch of different arcs in here, you want to use 180 when you can. So if I cover this up, 180 degrees would be from P to R. It's a semicircle. It's half of 360 degrees. So P all the way to P would be 360 degrees. P to R is half of that, because I covered up half the circle. So that would be 180. So to get P to S, I would do 180 minus 16. And that tells me this would be 164 for the arc, which is the same as the angle here. Okay, and then TR is 11, so they give us 11 is just from here to here, which is a radius. So we're doing the same thing that we've been doing. 164, we want to figure out what percentage of 360 that is. That's 45%, almost 46% of the circle's area. So it's like 173.17. So I will project the answers so you can just pause this screen and go back if you need to. But these are the answers for 1 through 9. But you're using the same process again and again. All the other ones are very similar, so you're having to use things like this is a 90-degree angle here. So to get from J to L would be 90. Since it's a 90-degree angle, it's a 90-degree arc. 52 of it is from J to K, so you could figure out what K to L is. So you just need to subtract these to get the rest of this. You could also use the fact that this K to M is 180. And this is 52 of it, so you need to figure out JM. Okay, so you have to use some semicircles, maybe 90 degrees, maybe the full circle, to figure out how much the degrees is for the shaded arc. And then they either give you the diameter or they give you the radius, so you either need to use the whole number or cut it in half. Okay, and then this was supposed to be shaded E to C on this one, in case you got one of the ones that was copied before. I remember that I need to shade this part. All right. 8 and 9 I want to do just in case you just need help on those. So the minute hand on the clock is 9 centimeters and travels through an arc of 252. So you want to be able to visualize what's happening on these or draw a picture. It's going to be helpful. So you have a minute hand on the clock, and it's 9 centimeters long. So it's like 9 centimeters long, and it travels through an arc. So it's traveling around. Minute hand goes this way, 252 degrees, and they tell us it's about 42 minutes. So it's somewhere over here. Okay, so it's the nearest tenth of a centimeter. How much area did the minute hand cover? So we want to know what this is. And this was 252 degrees is how much it traveled around. So that's the arc of the shaded portion. So we're going to do 252 out of 360 to figure out what percentage of the circle's total area we want. And then, if I'm going faster than this, you can pause it and just go back. Okay, the last one, a Ferris wheel, has a diameter of 225. Like I said, it's nice to draw these pictures out. If a passenger gets in a car, so he's on a Ferris wheel, he gets in a car typically close to the bottom, and travels 38 feet, so the passenger is going around the Ferris wheel circle 38 feet. We don't know how far that is, so we'll just approximate that it's not that far. When the wheel stops again to let another passenger on. Find the angle of rotation. So this time we're looking for the angle of rotation, and we don't know it. So the 38 feet is how much is traveled. So that is the arc length. I know this is the sector page, but this one's an arc length problem because he's traveling around it and it's 38 feet. So typically arc length is really related to sector. It's degree over 360, so that's telling us what percentage of the circumference 2 pi r, or pi times diameter, that we want. They told us this arc length is 38, so we fill in the 38. Find the angle of rotation to the nearest degree. We're looking for the degree. This time we don't know it, so we're going to put x over 360. And then 2 pi r, we already know the diameter, so we don't need to cut it in half to double it again. We can just use pi times diameter. So we'll, instead of using the 2 pi r, just use pi times diameter. That formula is easier because they've given us the diameter. Okay, so to get x by itself, the 360 is divided, so we would start off multiplying both sides by 360. Okay, so then we have x times 225 pi equals 13,680. Then we need to get x by itself, so we divide by 225 pi on both sides. When you're doing this in the calculator, you must divide each of these separately or put these in parentheses. Otherwise, your calculator will do 13,680 divided by 225, and then if you hit times pi here, it thinks that you're multiplying the pi in the numerator because it's doing order of operations. So you have to tell it that you're dividing by 225, and because pi is in the denominator, we're also dividing by pi. Okay, so x is about 19 degrees if we round to the nearest whole degree. Okay, so go ahead and try some of these other ones, and then just check them with the key. That was a couple minutes ago. I posted it on this video in the middle of the video. So, and then we'll go ahead and do just a couple examples for the area and then arc length. All right, area formula, we have A equals pi r squared. Circumference equals 2 pi r, or you can use circumference equals pi times diameter. First 4 problems, we're going to be finding the area. The 5 through 8 problems, we're going to be finding the circumference. So we want just the area for these. So we're just going to be using this formula over and over again. Okay, in order to use the formula, we need to know the radius. This one is given, so we're just going to plug in the 12. Order of operations says that we have to square 12 first before, so you do exponents before multiplication, so we get 144 if we square this, and then pi. So on your Math Excel, when it says what's the answer in terms of pi, you're going to actually put this with the pi sign behind it. You don't actually multiply by 3.1, that pi number. If it asks you to the nearest tenth, then you would multiply by pi. So 452.39 meters squared. Those are the correct answer, just in terms of pi and then to the nearest hundredth. Okay, on number 2, same thing, but they give us the diameter, so we need to cut this in half. So the radius would be just 9. 9 squared is 81. We have to do that first, so that's one answer. And then if I do 81 times pi, 254.47. So I'll let you do 3 and 4. Circumference formulas are here, so we're doing the same exact thing, but with a different formula. And I'm going to put the formula that corresponds to what I'm given. So I'm giving the radius in this, I'm going to use the radius formula. And I'm given the diameter in this, I'm going to be using the diameter formula. So I'll do 5 and 7. So the radius is 7, so we're going to plug in 7 here. Commutative property says that we can switch the order for multiplication, and we haven't changed the answer, so we can move the 7 here and make this 14 pi, which is the answer in terms of pi. If we times it by 14, we get 44 millimeters. No squared here because we didn't square anything, we just have a radius, so we don't have radius squared. So radius units is going to be the same as the circumference units. And then this one is just 58 times pi. 58 times pi, and the nearest tenth is 182.2. 21 for the nearest hundredth. Okay. When you are finding the radius or diameter, so if you are given the circumference or the area and you're trying to find the radius or diameter, you still use whatever they've given you, that formula. So circumference is given, and we're trying to find the diameter, so we use the formula that has diameter and circumference in it. Radius we're looking for, and we're given the circumference, so we use the one that has radius and circumference. Okay, and then we plug in what we know. So the circumference is 6597, and we need to get d by itself. This is just a number, don't let it fool you, so you're just dividing by the number pi. So it'd be like 20.21. Same thing with this, you're plugging in 2199 and solving for radius. So right now this is, you can multiply this first if you'd like. 2 times pi, I'm just going to divide it and type in 2199 divided by 2 and divided by pi. So 3.5 to the nearest 10. a couple more finding the radius circumference. I'll do area one. So sometimes they give you the area, and you're looking for the radius. They give you the area to the nearest hundredth. Sometimes they give you the area in terms of pi. So we'll do 12 and 14. So if they give you the area and looking for the radius, the formula is pi r squared. So you're starting with the formula almost every time. They give you the area, so you plug in what you know, and you work backwards to get r. So we need to move this pi off the side with r, so we divide it out. I'm only going to write 121 on the paper because these 9s will turn this into a 1. But I'm going to leave it exactly like this in my calculator and square root it. Okay, so the inverse of square is square root, so radius is 11, because all of these 9s would round this up to an 11. Okay. This one asks for the diameter, and we don't have a formula for diameter and area. So what we need to do is we need to use the area formula, the only one that we have, and find the radius. Once we have the radius, we know that the diameter is equal to the 2 times that, so we just need to plug in the radius that we get here and multiply it by 2. This one has a 90.25 and a pi sign, so you do carry the pi sign with the area, so that if it's in terms of pi, the pi's will cancel. So we divide by pi still, which cancels it on both sides this time. So r squared is equal to 90.25. And r is 9.5. So if the radius is 9.5, we plug that in, and the diameter is 19 meters. Okay, so all of these, even the bottom 6, same deal. You're starting off with one formula and using another formula, but you're just having to work backwards to solve for the radius and then plug it in. So if I just do 2 examples on this, we'll do the first 2. Find the area of a circle if the circumference is given. So we're going to be using the circumference formula, and I'm going to use the one that has r in it because the area formula has r in it. Oops. So you're going to solve for the circumference. This is 26 pi. We're going to plug that in. We're going to solve for r. So divide both sides by 2 pi. So 13 is the radius. And then once you know that, you plug that in to get the area. So in terms of pi, it'd be 169. Or 530.93. Okay, so you start off with the formula they give you the measurement of. So they give you circumference, you start off with the circumference formula. This one they start off giving you the area, so you start off with the area formula. And then you're looking for circumference. Okay, dividing by pi in this case gives us r squared equals 289. Square rooting that. R equals 17. Okay, so then you substitute in 17 for the radius here, so it's 2 pi 17, so 34 pi, which is 106.81 millimeters. So no square, because it's just centimeter, circumference, I mean. Okay, so hopefully that helps get the hang of the second sheet, and you should be able to finish those out. The key for that part is here, so you can pause the screen and reference this. Alright, and the last part is arc length. We'll just do a couple quick examples of that and move on to the second topic. So the formula again is degree over 360, so we're looking for a particular part of the circle's length. So it's a percentage of the circle's length, which is 2 pi r. Okay. So just like we had to do in the sector area, we have to figure out what degrees the arc is. The angle is 107, so the arc is 107. Out of 360 tells us we're really working with almost 30% of the circle. So 30% of the circle's length, which would be 12 pi if we were to multiply that. So 30 times 2 times pi times 6, it's like 11.21. So each time you're doing the length, you're doing that. So this one, again, you're going to have to do, they give you the 142, but that's this side. So you're going to have to do 360 minus that to get this arc. Okay, so then I'm going to let you do most of these other ones, but I want to go through like what these CD mean, because it's not anything shaded. So C to D is the shortest distance that you can get from C to D, which would be this arc. So that's the arc they're asking about. Okay, so they want to know what the length of this arc is, so you're doing what you did for 1 through 4. B to D would be a semicircle, so you can get this by subtracting 180 minus 68. And then that means that this arc is 112, and you can do 15 centimeters is the radius. Okay. And then solve that. The 3-letter ones, you trace the letters in order, and you don't ever change directions. Okay, so it's going to be N, M, and then P would be here. So we're talking about the 162 plus these 2 arcs. So N to Q is 180. 162 subtracted from that is 18. So both of these are vertical. These will both be 18. Okay, and then you, what is that? 180 plus 18, so 198. NR is 8, so that's the radius. Okay, so I didn't solve these out. You just have to plug this into your calculator, but you should get, let's see, for 5 it's 29.32. And 6 is 27.65. Okay, so a bunch of those for you to try. 16 and 12, don't be intimidated at the fact that they're word problems. Just try to draw it out what they're going through. They're going to be circles, so we know where the circles are. A 16-inch pendulum swings through an angle, so we have a 16-inch pendulum swinging through an angle of 40 degrees. How far does the tip of the pendulum swing? So looking for this arc, so you're doing the same thing. A car entered a roundabout from Mason Avenue. We don't know where Mason is, but it travels 280 feet. So maybe let's say this far. Okay. Then turned on to Perry Street. So enters a roundabout, goes a little bit, turns out of the roundabout. If the roundabout has a diameter of 225 feet, find the angle of rotation. So we're looking for this angle. Okay, so the answer is 280, sorry, is how much it travels. So we're looking for degree over 360, and then we can use diameter times pi since they give us the diameter is 150. So we're solving backwards for the angle this time. We know the answer is 280. The amount that it traveled around the circle is 280 feet. Okay, and that's it for the topic 1.